So if the screen is visible to you, let me know in the chat box. I think screen is visible to everyone. Okay. So hi everyone, I welcome you all in this session of geometrical optics, and this is the second session, or you can say second lecture. In the previous lecture, we have seen what is the properties of light and how light behaves as ray. Okay, and we have also see that what is reflection and what is refraction. What is reflection and what are the laws of reflection? How a mirror deviates a ray, or how the ray deviates after reflection. All that things, or all that formula we have did in the previous session. Hope you remember that. So if I just say here, what are the things? Just give me a second. So in the previous session, we have study about rays. What is rays specifically? Light ray. Then we have seen the reflection of light ray. What is the reflection? Laws of reflection. Okay. And the deviation of a reflected ray. Deviation of a ray from plane mirror. Plane mirror. Got it? Now in this session, what we are going to do, we firstly describe what is an object and then what is image. We will describing that how the mirror motion reflect, or the how the mirror motion affect the motion of an image and the motion of the object. So that's all we are going to see. Now firstly we will introduce what is an object. So object is nothing but the the actual form or the virtual form of the divergence or convergence of ray. In simple words, what does an object mean? From where the incident ray is coming, okay, or it appears to come, that particular point is termed as the point object. Okay. So object is decided by the incident rays only. The point object is that point from which the, or towards which the incident ray appears to converge. Okay. For example, like this. Here's the object and these rays are diverging. When ray move in this manner, at each and every point of time, the distance between any two points is increasing. This form is termed as diverging rays. Diverging rays. diverging rays. And converging rays are those at each instant after some instant of time, if the rays appear to come closer to each other, then that rays is converging. Okay, which is the ray which is moving away from a point, that is diverging, and the ray which moves towards the point, that is converging beam or converging rays. Now what the object is, देखो, you are seeing this pen. Why? Because a light ray coming from this point is going through your eyes and they are forming image. So this particular image, this particular object is a real object because it exists. That's why you are seeing able to see this. Got it? But sometime object mirror object can be a virtual point. How? Whenever the object, what is the definition of object? It is the point from where the incident ray is coming or appears to come. Okay. So at this point of time, if you will see, these rays are actually going to reflect back from here at this point. They are not going into the mirror. But if we extend them virtually, we will see that this is a point where this rays actually meet. Got it? Clear? Or it appears to meet at this point. So these particular rays or these particular points are called as virtual object. It's happens same in a way for the image also. Got it? So always remember, if from a point rays diverges, then that point is termed as real object. And if at a point ray appears to converge, not converging, it appears to converge, then that particular point is virtual object. What is an image? Image is also very simple. So as we decide the object by incident ray, we decide the image in the same manner for reflected rays. Okay. So image is nothing but the process of reflected ray. Okay. So image is decided by reflected or refracted rays only. The point image is at which the refracted ray again converges or appears to diverge from that point. Okay. For example, like this. If you can see here, this is an object. This is a real object because incident ray is diverging from this. So when incident ray diverge, that real image is formed, real object is there. So after the here the reflection is taking place. This is the reflected ray and this is also a reflected ray. I have told you where reflected ray appears to meet. सिंपल डेफिनेशन याद रखो इमेज की. जब भी रिफ्लेक्टेड रे आपको कहीं पे भी मिल रही है या मिलती हुई फील हो रही है, इट जस्ट योर ऑब्जर्वेशन की जो रिफ्लेक्टेड रेज है वो यहाँ पर मिलेंगी आकर. ठीक है, एदर दे आर मीटिंग और नॉट. क्लियर? So that particular point is the point of image. Here, if you will see these rays, reflected rays, after reflection, these reflected rays definitely meeting at this point, which means this point is nothing but the real image of the object. But if you will see here, in this case, we have this object, the rays coming from it, which is, it is an object, it is proving that incident rays coming from this point. It is an object. After deflection, or you can say after reflection from here, at this point of time, at this point, this is the reflected ray. What I have told you about image, from where the reflected rays are coming or appears to come. Okay, that particular point is image. So this reflected ray, after reflection, if you extend this, you will find that this ray is nothing but coming from it this point. Okay, you can say that this is the complete ray. It appears that this ray is coming from this point only. So that is why we will say that this is the virtual image of the object, because here nothing is here, na? This is the virtual space. Virtual space. What is behind the mirror? There is nothing behind the mirror. But if the image is forming behind the mirror, which is, we can say that is a virtual image. Got it? Now, I think these definitions are clear to you. If you have any kind of doubt, you can ask right now. ऑब्जेक्ट और इमेज के बारे में सीधी सीधी एक बात याद रखनी है. ऑब्जेक्ट इज द related to incident ray and image is related to reflected ray. Object is that point from where the incident ray is coming or appears to come, or image is nothing but the point where from where the reflected rays are coming or appears to come. Okay, either they are coming or not, this is not the case. They should appear it like this. Got it? Now we will introduce the object and image velocity in the plane mirror. Got it? Now from here I am also introducing some concept related to plane mirror. So you take up the heading some concept related to plane mirror. What are those concepts? The first one is image is equidistant from object, and this is only applicable in the case of plane mirror only. Got it? Second thing is, if object is placed perpendicular to the plane of mirror, then image gets inverted. Okay, for example, let's say this is the plane mirror and we have an object as this plane at this point, and this object is at a distance a from the plane mirror. Perpendicular distance you have to measure always, the line connecting perpendicularly to the point and to the image. So the image will also form at equidistance from the plane mirror but in opposite direction. This is also a. This is image, this is object. Clear? Any kind of doubt in this? Yes and no? Mentioned in the chat box. And please utilize this function as a chat box. You can ask any doubt if you want. Okay, you can unmute yourself and then also ask. Now, suppose what I have said in the second point, this is for first point. We have an image like this. This point is A, this point is B. So I have told you, if the object is placed perpendicular to the plane of mirror, a plane of mirror to ye, this object is perpendicular to the plane of mirror. You can see here 90 degrees. So I have told you that image will be inverted. For that formation of image, what you have to do? Just measure the distance of this point which is, let's say, A, then this point is at equidistance from this mirror. Image will be here, and rest of the image will be like this. If A is related at this point B, this is also this point B, which means from here to here you can see, although the image of B got inverted also. Clear? So you can see here the image got inverted. Here you have A and B, here you have B and. Okay. So image got inverted when it is placed perpendicular to the plane of mirror. Got it? Chalo. Let's just talk about the velocity of image and velocity of object. So here we will use this concept only, the fundamental. We are using the fundamental concept only. This is the plane mirror. Okay. And let's say the object is at here at this point, and this is the distance of image, sorry, object. So similarly, at the equidistance, object image will be formed, and let's say this is that one. So here it is object, and here it is image. Got it? Now we know that the distance of image, let's say this distance of object we are denoting by u, and this distance is also be u. Got it? So we can say the fundamental concept, the distance of image or the distance of object, distance of object with respect to mirror is equals to distance of object, distance of image with respect to mirror, but in negative direction. Can we say that? Yes, we can. Now, here if you differentiate this term, let's say distance of image object we are representing by u only, and this is we are representing by v only. Okay. So we can say that du by dt, or let them we denote by velocity of object with respect to mirror, VOM, is equals to velocity of image with respect to mirror, is going to be same. Clear? If this is the case when the mirror is not moving, ठीक है, only object and image are moving. So यहाँ पे जो मेरा image है, sorry, the mirror है, वो क्या है? Stationary. Mirror is stationary. Now अब देखो यहाँ पे ऑब्जेक्ट की दो डायरेक्शन में मूव कर सकता है. सपोज ऑब्जेक्ट की मेरे पास दो डायरेक्शन में वेलोसिटी है. Object have this velocity v. This is the velocity of object with respect to mirror, and this is, let's say, the velocity of image with respect to mirror. Got it? So if you resolve these velocities into two component, that would be velocity of image object with respect to mirror parallel, perpendicular, sorry. This is the velocity which is perpendicular to the plane mirror, and this is the velocity of object with respect to mirror parallel, which is parallel to the plane of the mirror. ठीक है? In similar way, velocity of image with respect to mirror perpendicular, and this is velocity of image with respect to mirror parallel. Okay. So it is very clear to say that if mirror is not moving, let's say mirror is not moving, then this velocity of object, okay, parallel, अगर ये मेरा मिरर है, लेट्स से दिस इज द मिरर और ये मेरी ऑब्जेक्ट है, अगर मैं ऑब्जेक्ट को ऐसे ऐसे करूंगा तो इमेज भी साथ साथ में ऐसे ऐसे ही करेगी ना। जितनी ऊपर आप ऑब्जेक्ट को लेकर के जाओगे उतनी ऊपर इमेज भी बनेगी। कंडीशन इज दैट कि मिरर विल बी स्टेशनरी, सो इट इज द मिरर, दिस इज ऑब्जेक्ट, लेट्स से, and it is moving up and down, so image here will form up and down, move in the same direction. So we can say that first point to note here is velocity of object with respect to mirror parallel is equals to velocity of image with respect to mirror parallel. So these parallel velocities are equal and in same direction with each other. This is the condition when mirror is not moving. है? ठीक है. Now the second condition is that velocity of object with respect to mirror perpendicular perpendicular is equals to minus of velocity of image with respect to mirror perpendicular will be negative in direction, and this is very pretty obvious to say कि if देखो ये मेरा प्लेन मिरर है, अगर मेरा ऑब्जेक्ट ऐसे जा रहा है तो मेरी इमेज भी तो इस तरफ ऐसे आ रही होगी क्लोजर। जितना क्लोज मेरा ऑब्जेक्ट आ जाएगा, जितना क्लोज ऑब्जेक्ट आता जाएगा उतनी क्लोज इमेज भी बनती चली जाएगी, which means we can say the velocity which is perpendicular to the plane of mirror is negative in the direction of velocity of image perpendicular to the mirror. Got it? So this is the second relation between them. Now it is happening only for when the mirror is stationary. Now let's say in the second case, mirror is also moving. Mirror is also moving. Second case is that mirror is not stationary or is not at rest. Is not at rest. Clear? If mirror is not rest, which means the velocity of mirror will play a role here. And let's say for this case, hope you note it down. ये ऑब्जेक्ट है, it has this velocity of object with respect to mirror. This is image and this is the velocity of image with respect to mirror. And now this time this mirror is also moving with certain velocity, which is velocity of mirror with respect to ground. Okay. So if you resolve into two component, it will be velocity of object with respect to mirror perpendicular. This is the velocity of object of mirror parallel. Similar way में this is velocity of image with respect to mirror perpendicular. Velocity of image with respect to mirror parallel to the plane of mirror. Got it? We can also resolve this Vm vector. This is velocity of mirror perpendicular to its plane, and this is velocity of mirror parallel to its plane. Okay. So the concept here is this velocity of image parallel and velocity of image parallel will have no effect of this mirror velocity in parallel direction. क्योंकि जैसे जैसे मैं मिरर को मूव करूंगा वैसे वैसे मेरा ऑब्जेक्ट भी साथ साथ में मूव करेगा. ठीक है. Object is also moving with respect to mirror, and mirror is moving like this, so image will also move in this way. So there is no addition point in that. So this concept, that velocity of object with respect to mirror parallel equals to velocity of image with respect to object parallel with respect to mirror parallel is same. But in the second case, now we have the mirror velocity also. Got it? We have the mirror velocity also in the perpendicular direction. So we would like to open this expression, so it will become velocity of object with respect to mirror wheels, velocity of object minus velocity of mirror with respect to ground. Now minus velocity of image minus velocity of mirror. Now this minus sign will multiply inside. This will become that velocity of image is equals to velocity of image is equals to 2 times of velocity of object plus, or let's say just explore it. This will become velocity of object minus, we can take minus Vm vector is equals to minus Vi plus Vm. This Vm will get this side, so it will become velocity of image is equals to 2 times of velocity of mirror minus velocity of object. So the velocity of image perpendicular to the plane of mirror get disturbed, and it is given by 2 times of velocity of mirror minus velocity of object. Got it? Now, to solve this example, we have the concept right now. And the object is moving. An object moves with 5 meter per second towards right, while the mirror moves with 1 meter per second towards left, as shown. Find the velocity of the image. So I'll show you. This is the image. This is the mirror, and this is object here. This object is moving towards right. Let's say this is right direction, and we are assuming that right direction is positive and left direction is negative. Noted? Left direction is negative. Now, mirror is moving with velocity in the left direction also. This mirror is moving in this direction with 1 meter. Object is moving with velocity 5 meter per second. 5 meter per second. Okay. Clear? Now we know that from the previous relationship, velocity of image parallel equals to velocity of image parallel. देखो अगर आप इसे एक्सप्लोर भी करोगे ना, ओपन अप करोगे, वेलोसिटी ऑफ ऑब्जेक्ट विद रिस्पेक्ट टू मिरर पैरेलल, velocity of object with respect to velocity of image with respect to mirror parallel. Now you can open it in the absolute term, velocity of object minus velocity of mirror. It will be velocity of image minus velocity of mirror. So this mirror velocity cancel out, velocity of image is velocity of object, but in parallel direction. Got it? But this velocity, if you will see, that is given in the question is perpendicular to the mirror. So this parallel velocity becomes zero here. Okay. Now velocity of image perpendicular is nothing but 2 times of velocity of mirror minus velocity of object. Now Vi is equals to 2 times, you need to put velocity of image as negative. Why? Because this direction we have taken as negative. Minus 1 minus into minus 5. So it will become minus 2 plus 5, which is 3 times 3 meter per second. So if you combine that, velocity of image is nothing but velocity of image parallel plus velocity of I cap into sorry. So velocity of image you can write, because here the velocity of image parallel is 0. So only remaining velocity is perpendicular. So velocity of image is equals to velocity of image perpendicular, which is given by 3 meter per second. Okay. Any kind of doubt in this? Any kind of doubt, guys? Yes and no. Yeah, I would like to repeat it. देखो, we have studied in the previous concept the velocity of image parallel is equals to velocity of object parallel. Parallel means like this. If the image is, if the object or the mirror is placed like this, an object is here. So if you move the mirror in this way, so object will also move. Suppose the mirror is moving with 1 meter per second, object is also moving with 1 meter per second. तो जो इमेज है वो भी 1 मीटर पर सेकंड से ही ऊपर जा रही होगी, जहां पे ऑब्जेक्ट होगा वहीं पे इमेज बनी. ओके. सो वेलोसिटी ऑफ इमेज पैरेलल विद रिस्पेक्ट टू मिरर इज इक्वल्स टू वेलोसिटी ऑफ इमेज विद रिस्पेक्ट टू मिरर पैरेलल. ये तो दोनों बात सही है. अब यहाँ पे जो हमें वेलोसिटी गिवन है विच इज 5 मीटर पर सेकंड टुवर्ड्स राइट एंड 1 मीटर पर सेकंड टुवर्ड्स लेफ्ट ऑफ ऑब्जेक्ट एंड मिरर. अब ये जो टुवर्ड्स राइट और टुवर्ड्स लेफ्ट है, दीज आर द परपेंडिकुलर वेलोसिटी. वी हैव डिस्क्राइब दैट if there is a velocity here, this component will be v perpendicular and this component will be v parallel. Got it? Parallel component is not there, so parallel velocities will also 0. Velocity of image perpendicular is nothing but 2 times of velocity of mirror minus velocity of object. From the previous concept we have seen it. You can take a look here. Got it? We have put the value with sign. So left we have considered negative, so we are putting this velocity of mirror as negative sign, minus 1. And the right we have considered positive, so we are putting this velocity in this direction as positive, sorry, negative. Okay. So here देखो यहाँ पे एक mistake हो गया. We have put the 5 also as minus, but the 5 we have to consider as plus. So it is plus. This will become minus 7. Minus 5 minus 7 meter per second. How the image can move in the opposite way of the this. ठीक है. Clear? अब clear हुआ आपको JNV drawing? We have just put at the values using formula. Any kind of doubt in this? Everyone? Is it clear to everyone? Okay, very good, everyone. So I'm giving you one more question. Let's just try to solve it and then let me know what is the answer. Okay. Suppose we have a plane mirror which is moving in this direction. Let me solve this for you first of all, then I'll give you. This is the velocity of mirror, which is 5 meter per second, 4 meter per second, and the angle is 60 degree. This angle is 60 degree. Now, this is object and this is image. This is the object which is also moving with this velocity at an angle 60 degree, 60 degree with velocity. Now, what is the velocity of image here? You have to tell me. So to resolve these, resolve this vector into two components. First is parallel and second is perpendicular. Got it? My voice is audible to everyone and the screen is visible to everyone. So velocity of object parallel will become here what? 2 cos 60, which is 2 into cos 60 will become 1 by 2, 1 meter per second. And velocity of object, ये velocity of object with respect to mirror है, और velocity of object with respect to mirror perpendicular is nothing but 2 sine 60. This component 2 into root 3 by 2, which is root 3 meter per second. Now, velocity of object, we know the first concept that velocity of object parallel is equals to velocity of image parallel. So it will become velocity of image parallel is equals to 1 meter per second. Velocity of image perpendicular will become 2 times of velocity of mirror minus velocity of object. 2 times of velocity of mirror is nothing but, अब देखो velocity of mirror को भी दो डायरेक्शन में रिजोल्व करना पड़ेगा, पैरेलल और परपेंडिकुलर. So this component will be velocity of mirror perpendicular, which is 4 cos 60. 4 into 1 by 2, which is 2 meter per second. और इसके पैरेलल कंपोनेंट की तो नीड ही नहीं. So 2 times of velocity of mirror perpendicular is 2 meter per second minus velocity of object is 1 meter per second. Sorry, velocity of image perpendicular is root 3. So this will become 4 minus root 3 meter per second. ठीक है, क्लियर हुआ? एनी डाउट इन दिस? कोई डाउट है इसमें? Yes and no, any kind of doubt? समझ में आया सभी को? Let me know in the chat box. I'm giving you one more question to solve. This is the mirror which is moving in this way with velocity 5 meter per second. Okay. An object is moving in this way, opposite way of it, with velocity 2 meter per second. Find out the velocity of image. Everyone, try to solve it. Bhagat, Bharat, Christina, Priyadarshini, Deva, and Harish, JNV, Kokrajhar, Rohing, Madhukar Reddy, Nagashri, Pallavi, Praveen, Priyanka, Rohit, Sneha, Sunanda, Suraj, Tejashwani, रुक्मणी, वेंकट, जेनवी, शाहीन और वीर प्रसाद. Try to solve it and let me know the answer. I am giving you 1 minute to solve this question. Okay. Please try to solve this question. Not this one. This one. This question I have given. 2 meter per second moving left, 5 meter per second moving right. Try to solve it, everyone. Are you guys solving it? Getting some too? Okay. देखो velocity of image calculate करने के लिए we know that only one component of velocity is there, which is velocity perpendicular. So directly apply this formula. Velocity of image is 2 times of velocity of mirror minus velocity of object. 2 times of velocity of mirror. Now this comes to the sign direction. If you are taking this direction as positive, so you have to take the opposite of it as negative. So I'm taking this direction as positive, so it will become 2 into 5 minus velocity of object will become minus 2. It is 10 plus 2, which is becoming 12 meter per second. Got it? This is the velocity of image. Now this question, in this situation shown in the figure, find the velocity of image. Again देखो ऐसा question मैंने किया है अभी. You have to resolve the two component, velocity of object and velocity of mirror also. It is becoming as 10 cos 60, which is 10 cos 60 is 1 by 2, 5 meter per second, and this is velocity of mirror perpendicular. ठीक है, with respect to, sorry, velocity of object with respect to mirror perpendicular, and this is the velocity of object with respect to mirror parallel. अब parallel वाली तो सेम ही होगी. ये कितनी हो जाएगी? 10 sin 60, which is 10 root 3 by 2, ultimately 5 root 3 meter per second. So velocity of image तो सीधा सीधा parallel तो सीधा ही. Velocity of image parallel, velocity of object parallel, which is 5 root 3 meter per second. इस पे मिरर वेलोसिटी का फर्क ही नहीं पड़ेगा. ठीक है. बट वेलोसिटी ऑफ इमेज परपेंडिकुलर is equals to 2 times of velocity of mirror minus velocity of object. Image object is moving in this way, which is positive, and mirror is moving in this way, which is negative. Clear? So negative way में that velocity will be 5 cos 30, 2 times of 5 cos 30, which is root 3 by 2, minus 2 times of velocity of object is, अब देखो ऑब्जेक्ट की वेलोसिटी कितनी है, ये कौन सी परपेंडिकुलर वेलोसिटी इज नथिंग बट 5 मीटर पर सेकेंड. यही तो है 5. सिर्फ वेलोसिटी ऑफ ऑब्जेक्ट परपेंडिकुलर 5. तो दिस विल बिकम 5 इंटू रूट 3 माइनस 1. देखो मैंने इस वेलोसिटी ऑफ मिरर को पॉजिटिव कंसिडर कर ली, 5 रूट 3 बाई 2. तो वेलोसिटी ऑफ ऑब्जेक्ट इसके ऑपोजिट है, तो मुझे इसे भी नेगेटिव कंसिडर करना पड़ेगा. इसका मतलब ये हो जाएगा प्लस. दिस विल बिकम 5 रूट 3 प्लस. मीटर पर सेकेंड। क्लियर है? सो आई हैव लॉन्च्ड अ पोल। किसी को अगर कोई डाउट है तो यू कैन आस्क राइट नाउ, अदरवाइज मार्क योर अटेंडेंस बाय रिपोर्टिंग इन दिस फीडबैक फॉर्म। ठीक है, ट्राई टू आंसर ऑल द क्वेश्चन गिवन इन दिस, ईच एंड एवरी क्वेश्चन। ओके, और किसी को कोई कॉन्सेप्ट नहीं समझ में आया तो जस्ट लेट मी नो इन द चैट